Good afternoon, everybody. Thank you for joining us for another session of EI Live for K-12 students and educators, brought to you by the Earth Institute at Columbia University. So my name is Cassie, and I'm the director for the Office of Education and Outreach, and a big part of my job is to bring our scientific research to different audiences. For those of you who aren't familiar with the Earth Institute, our core mission is to foster a greater understanding of the science behind sustainability and the climate crisis, as well as what we as global citizens can do. Experts to make up the Earth Institute include earth scientists, economists, business and policy experts, and specialists in public health and law. The Institute is actually made up of more than 24 or so research centers and several hundred people who collaborate across many different disciplines and departments across Columbia University. What we're hoping to do with these sessions is to introduce you to our interdisciplinary work through our experts. And we will have sessions until next Monday. And we will, so in addition to today's session, we'll have one session on Wednesday, and our last EI Live K-12 session will be next Monday, June 29th. If you have any questions about our remaining sessions, please do not hesitate to contact me. So today, we're going to hear from Radhika Iyengar of the Center for Sustainable Development and Lex Van Hen. And both of those centers are centers within the Earth Institute. Today, they're going to discuss how they used citizen science efforts in India to detect fluoride in water. An example, they'll help us better understand how citizen science can be used on a large scale and contribute to scientific research in very important ways. If you're having any technical difficulties, please email me directly. And without further ado, here's Lex and Radhika.
Thank you, Cassie. It's my pleasure to be here. Lex and I are going to take you to some villages in India, in central India. So we'll take you to a journey of some villages. We'll visit some villages in India. We'll go over our next slide. So this is a bit about me. I am from Bhopal. Bhopal is at the heart of India. It's actually located at the central part of India. And I came here to do my PhD from Bhopal to JFK. So here is my long flight from Mumbai to JFK. I came here to do my PhD a couple of years back at Columbia University. So before we get into more action and more of our study, it will be great if we can just do a short poll just to take some of your opinions. And I think Cassie will help us to facilitate this. So Great. Here are some questions. Mm-hmm. So what is the source of most of the water that you drink? And here are 4 options. If you can all click to the answer that is most appropriate for you.
Let's see. So far, I'll share the results in a minute, but as people are responding, so far, the number 1 answer is number 1, the tap connected to community and city's water supply. And we have 1 answer each for number 3 and 4. So purchase bottled water, and 1 is not sure. That's most of the people. So here are those results.
Great. So it's mostly tap water.
Yes, it looks like mostly tap water. Yeah. Mm-hmm.
Great.
And do you want me to launch the second poll, Radhika?
That will be great, Cassie.
Okay, great. So the second poll, the question is, if you drink from a tap, what is the source of that water? Pretty evenly split right now between number 1 and number 2, and 1 person is unsure.
Interesting.
Yeah. Mm-hmm. All right, so there are those results. So we actually ended up with more people who voted that their water comes from a well and groundwater. Great, and then we will launch the third poll here. which is, do you think that water requires treatment before reaching the tap? All right. Everyone has said yes so far.
Great.
Yeah.
So great answers.
Right. So there we go with the results of that poll.
Great. So thanks for actually answering these questions. We are just preparing to see what we, in this journey to the villages of India, we'll see where people drink, their water from. So now imagine you're going to a rural parts of India, and where this infrastructure is very, scarce, and there's a lot of, problems in basic amenities. So what are the options? What would be the options for drinking water for these residents in rural India? So I don't know if you guys want to use the chat box, or Cassie, do you think we can see the answers in the chat box while
Yeah, so I would say for our viewers, if you'd like to answer this question, use the Q&A box for the responses, and then we'll keep track of those. So let us know in rural India where some of this infrastructure might not be available. What are the options for people who need to access water? So let's give folks a little bit of time to respond. Okay, we have a few responses. Well, mostly from wells, taking it straight from rivers, water wells, and well and groundwater.
Oh, terrific answers. So I think we don't need the presentation. Lex, looks like people are already aware of the sources. So that's fantastic and very, very encouraging. So here are some options. We've seen people just use water from, just open surfaces, open sources, again, untested. Then you have a photo here with like a, tap water. Most of us get water from the tap. There is a filter here. If you're lucky, people would get, filters installed. Otherwise, there'll be all these community taps in parks and other places. Usually people fill their water from there. So various different options. Usually people in India, rural India, they have very different sources of water. So we want to take you to back again from JFK, where I came from, back to Bhopal, because that's where our study actually started in 2018. Lex and I have been working on this study since then, and clearly learning a lot. This study is based very close to Bhopal. So this is where my hometown is, in Bhopal in central India. And then if you travel from here to the west side, there is this district which is primarily rural. And here is Alirajpur district, very close to another state, Gujarat. That's the Gujarat border. And here is the district. So here is the map where you can see the full map of India, and it's here. This is where our study is based. This district is called Alirajpur, and around 28,000 people live here. So why did we decide to actually test, the water? So testing of water is for, the fluoride content. And if many of you would know that if there is high fluoride, you start having these dental fluorosis problem, which is this browning of the teeth. There is this line that comes across the, teeth, and usually, if you keep having water which has high fluoride, then there is tooth decay, browning of tooth leads to tooth decay, and they fall off. And then also with, if you keep consistently having the water for years, your limbs may get weakened, and there may be many other issues along with your nervous system in the brain. All that could be affected as well. So it's really important to test the content of fluoride in the water. And
can I add something, Radhika, for a second?
Sure.
So I'm sure you've heard about fluoride before. You've seen it in your toothpaste, and also many cities, including New York City, there's actually an addition of fluoride to the water, and that is to prevent tooth decay. And what is rather special about fluoride then is that you need a certain level And New York City, it's 0.7 milligram per liter. The units don't matter so much. But as soon as you get into 1, 2, 3 milligram per liter, that's when children have these marks on their teeth or worse conditions in the bones and the limbs. So some fluoride is necessary, and that's probably why you've heard about it before, those of you who are listening. But in certain parts of the world where people drink water directly from the ground without any treatment, there can be too much fluoride. And that's the area that Radhika took me to starting last year.
And there were many, just to add to what Lex said, that there were many rumors that, oh, the children are not brushing their teeth, and there were many other things going on, but very few people could link the tooth decay to the high fluoride in the water. So in Alirajpur, where is this district where we have the study going on, the main source of water is actually a hand pump. And not sure how many people have seen this hand pump. This girl standing behind has to actually push this handle down or this lever down, and then the water comes out. You have to continuously do that so that there is water that comes out. And usually couple of houses or at least a village share these hand pumps. It's a community hand pump. This one is based in a school, so schools also have hand pumps because they require for the kids to have water. So this is like a hand pump in a school. This is a source of water that the kids have in the school. So initially, what we do when we do a field work or a study is first we go there and start talking to people. So many students like you, if you see the picture here, this is a school based in Alirajpur, and we went there and we are talking to many students to know from them, what is fluorosis, what is their impression of fluorosis, and have they seen, this browning of teeth before? And there were a lot of discussions. We had more discussions and more discussions. We spoke to many more students there, and everyone was very interested to know about fluorosis and how we can actually avoid this browning of teeth, because it was very clear that they had seen a lot of children with browning of teeth in the village. This was followed by pilot testing of the wells. You see Lex is there, and then Charlotte and Sachin and I. We are all surrounding a hand pump, and we are basically trying to test to see what is the range of fluoride in this particular district. And the level of fluoride range from 0.5 to 10 milligram per liter. And permissible level is by WHO, World Health Organization has recommended that you should have 1.5 mg per liter. So as Lex was saying before, that some amount of fluoride is necessary, and it should be below 1.5. In New York City, it is around 0.7 milligram per liter. But in this area, it ranged from 0.5 to 10. And as you can see, 10 is a lot. So there was a lot of danger of fluoride in this particular district. Then we conducted a lot of trainings for some college students, and there were like 60 college students who attended our training. They were doing masters in social science, social work. So they are social science students, and they were learning how to do fluoride testing, which is, again, I feel that this was a very good lesson for me also, because this was the first time I was learning how to do fluoride testing from Lex. And here you can see in the photo, Lex is actually using the cell phone to see how we can store the data and record the data. We'll get into it a little bit later. So the training included 60 college students, and there were 3 main objectives of the training: how to test fluoride in the water, and how do you upload the data using your cell phone, and how do you share the results with the village that you are doing. So it's not just testing and uploading the data and not talking to anyone. It was also all about sharing and telling everyone what the result was. Also learning to do the test yourself. So here we have a student who has this range of fluoride samples. They are different colors. Many students, including me, this fluoride kit was very new to us, and we learned how to test the fluoride in the water. And many of these students actually came from the same village that they were testing the water in. So they would go back to the villages, and would, in their field work, they would test the water from the same village, which they never really did before. So this was really an important task that everyone was doing. After
Can I interject for a second? Do you mind going back to the previous? I'll say a couple of things about that, and I'll also respond to an online a live question that I got, if that's okay, Radhika.
Sure, let's.
So one person asked, why is the fluoride in the water there to begin with? And I think that's a good question. And it has nothing to do with pollution. There's fluoride everywhere in rocks, including in the rocks of this particular study area. And especially if there's very little calcium in the rocks, then this fluoride will be released to the water. So it's a natural process. It doesn't affect groundwater everywhere. It affects this part of India in particular, Madhya Pradesh. It affects some parts of the Indus River Valley in Pakistan. Perhaps the most affected area in the world is the East African Rift, so Ethiopia and Kenya. So those are countries where the water can be very high in fluoride. So natural reasons, it's geochemistry, and people are still studying why it is present in some areas and not in others. I wanted to say a couple of words about the colors here, if that's okay, Radhika.
Yeah, sure.
So if you look at it carefully, you will see that there are various shades of pink and yellow. And the first three tubes, in fact, they indicate what the water looks like if you add, I forget what was it, 10 or 12 drops of the reagent that Radhika had brought back from India, and then we tested it in the lab. So the first three are for 0, 1.5, which is this World Health Organization limit, and 4. And so one of the things that was a bit tricky to get across is that usually you think about a colorimetric reaction, that responds to something like fluoride. It could be arsenic. You think, well, the stronger the color, the higher the concentration. And so this actually turns out to be the other way around. When there's no fluoride on the water, then the solution remains pink, and it discolors towards yellow as a function of the amount of fluoride. And so that, I think initially in the training, maybe you remember, Radhika, I think that could cause some confusion. The other thing that I wanted to say is that we had to improvise a bit when we arrived there. We wanted to use a locally available kit. We also learned that the color doesn't stay forever. And so you may have standards like this 0, 1.5, and 4 at the beginning of the day, but we realized that by the end of the day, those would already have changed color and faded. And so if one of these students analyzes a sample and compares it to the incorrect scale, they would get the wrong result. And so what we had them do every time was analyze a known, which was this 1.5, the threshold, and the sample, and then always tell us what is the relative color between those two. It's a relatively simple chemistry, but to get people to do this without errors, especially if the color becomes weaker with concentration, it took some training and some trial and error on our part as well. Thank you.
Next, one question actually I had for you. So when scientists do these fluoride, related tests, do they usually do it in labs, or do they actually go there and do it like the way we did actually in the villages with people, and this is all the results were for people? What is the new trend?
Right, so that's actually still a topic of discussion in the field of sort of water quality, analytical chemists, policy people. In New York City, certainly a sample would be collected from multiple points and analyzed in the lab using the latest methods. But as you and I, we experienced, right, Radhika, if you go into a village in Madhya Pradesh, there will be dozens of wells, and there is no simple way to make these measurements. And so what I, in fact, for the last at least decade or two, have been arguing that if you are in a setting where the lab is not easily accessible, and yet people drink water from wells, and one well can be high and one well can be low right next to it, even though the kits aren't as precise, I believe that the population will be better off by using kits. Another complication if you use a lab is that someone has to go to the well, collect the sample, go to the lab, analyze it, and then bring the result back. So the logistics of that are much more complicated. And whereas if you have a kit, you're there, you get there, you talk to the person, you ask for permission, you make the measurement, and you provide the result right away. Obviously, a subset of the sample should be analyzed in the lab as well. And as you know, Radhika, we still have to make some progress on that front. Yeah, no, and I can tell you, among researchers, not all my colleagues will agree with me on this particular topic. It'll be interesting to hear from our attendees later what they think.
So this idea of like citizen science was used, where we are actually involving citizens who are affected by this, and citizens who don't necessarily have science background were also were helping us to do this, and I was actually one of them learning also. So then as Lex was saying, that we have to convey the results also, and so what we did was we did all the students there, they conducted the tests, and they also painted the water points. It had to be a visible color because it had to show everyone, and not everyone there, it's actually Alirajpur has the highest illiteracy rate in India. So it's one of the most marginalized districts in India. And so we had to make it very visible for people who don't necessarily can read 1.5 mg per liter. And then, then even if it is 10 mg per liter, what does it really mean? So we had to color paint it. And here we have like a blue color, which basically shows that this well is safe. It has permissible levels of fluoride, and the water is safe to drink. And whereas the ones that were high fluoride, 1.5 mg or more, we had put a yellow ring around the hand pump. So it was a very visible color that everyone was able to see. And then all the students also, you see a cell phone here. This girl is actually recording the results of what they found in the hand pump. So where did all that result go? So the next thing is also, once they painted it, this is a blue color painted. So the students were then asked to convey the results to the population, or to the students, to the other children or villagers who are standing there. So I don't know if anyone has been hearing me. What is this blue color? Can they write it in a Q&A box? Maybe what does this blue color signify? If the hand pump has a blue color, is this water safe to drink? Maybe you could write it in a Q&A box.
We have one answer that said the blue color means the water is safe to drink.
Oh, great. Perfect. 100 marks on that answer. So yes, so Q&A, so basically, it shows that, if you have a blue color mark, that means the water is safe to drink. And that is what we had to convey to everyone who's standing here next to the water pump, hand pump. We had to tell them that, yes, this is what it means. Now, all this data that was digitally collected, it went to a database online, which Lex was very carefully seeing, what type of data is coming in. And you see all these blue dots, they are actually hand pump data points. And the blue dot again means that they are all safe wells. And if you see the yellow dots, they are all the wells that have high fluoride. So maybe in this map, in the Q&A box, if you could write down your observation of what does it show. Does it show anything? I don't know, Lex, we are going off the script, but I hope that's all right.
That's all right. That's all right.
So are there any observations on what does this map really show?
So we have a couple of thoughts here. So unsafe areas coexist with safe areas. There seems to be quite a lot of safe wells. There are also more safe water pumps than unsafe water pumps.
Great. So all very good answers. And yes, there are unsafe wells that coexist with safe wells. There are blue points more. And then the yellow ones seem to be concentrated probably. We'll see the larger map with more data points soon, but these are some of the observations. Alex, do you have a...
Yes, I wanted to say maybe a little bit more about the smartphone. So one thing that has changed a lot in this type of work is that the students in the college that Radhika had indicated, the social work students, most of them had a smartphone. And that is an enormous help for these types of studies because it allows you, with a very simple form, you can set up a simple form in Excel, in fact, and have the students record the information, the GPS coordinates, the location, a picture of the well. You're going to see many more of those in a minute, and the test results and the colors of the pink and yellow tubes that you saw. So this has really been sort of, to my mind, this has revolutionized this type of work where you need granular information at the very local scale, and yet that is centralized efficiently and where some quality control is provided. So we hope to expand this approach in sort of in parallel with the further, the greater use of smartphones everywhere. So I think you're right. So I think we reached the map stage, right, Radhika?
Yes, Lex.
So I think what we want is now maybe not so much this one. We can go back to the previous one, but I think Cassie was going to type in the link. So you should, maybe let's go away from this slide because otherwise it gets a bit complicated. So we would like to ask the participants to copy that link. And I'm going to do the same thing to make sure it works and navigate there. And then tell us in the chat box what you see. Right, so what you could do, Cassie, you could already post the first poll. So sure. If things work out, the participants should see, again, India and zoom in on the area. And we have a question for you before you, you zoom in all the way. And so the question is simply, look at the field of data points. So they're yellow and blue markers. And the question is, what distance in east-west direction was covered by the testing by these students? They did this over several months on the weekend, right, Radhika? And you can see they worked very hard. And you should be able, if you don't zoom out too much, there's a distance scale in the lower left of the My Maps page. And why don't you respond and just tell us what the east-west sort of the dimension is of the sampling. Is it 1 mile, 10 miles, 20 miles, or 100 miles? And then as soon as Cassie gives us the result from that, then we'll know that you are coming along and we can go to the next question.
Okay. Great. So we've had a response to, I've just launched the poll. So for those of you who are perhaps still looking at the map, if you go back to the Zoom window, there is the poll that's in progress that is asking the question that Lex has just gone over. We did have a participant say that they're, based on the Google map, that there are a lot of unsafe wells concentrated in one area. Mm-hmm.
Yeah, that's a good observation. We'll build on that because that will have also implications for solutions to the problem that we'll discuss.
Mm-hmm. So for the poll, we've had one person, one response for a mile, and then one for 100 miles.
Okay. All right.
And
so
one for 20 miles.
Yeah. So I'm wondering whether I should share my screen for a second, or does it get too complicated, Cassie?
No, you can go ahead. So if you would like to, so I'm going to share the results of the poll, and Radhika, if you can stop sharing your screen, then Lex can share his screen. Okay, good.
But I see that the dominant response was 20 miles.
Yes.
And we'll look at that together. So this, by the way, again, combined with the smartphones, the fact that we have access to this makes this type of work much easier. Let me go. So here's my version to the map. So I zoomed in. So I've kept the points sort of clustered together, and there is a scale down below. And so indeed, somewhere between 20, 25 miles was the right answer. And This is, by the way, a tool that is really useful for you if you get to do some sampling with GPS coordinates. Just look for Google My Maps. If you have a Gmail account, you can upload an Excel file and make maps like that. It's really simple and it's a lot of fun. I think we're ready for the next question, Cassie.
So before the next, I'll launch the poll. We did have a question come up from one of our attendees about the series of blue dots. So the participant has asked, Casey, has asked, would that mean that different types of rock with different levels of fluoride may be more likely to be found in one area than the other? And do the locations depend at all on the environment or the climate in a specific part?
So very good questions. And I wish I had a clear answer for you. That's sort of the research that we're still doing. Clearly, the climate is not so different over a 20-mile distance, and so it cannot be the only reason. The rocks, they do vary, and when you drive around and there's some road cuts, you can see some variations. So most likely the vicinity of some calcium-rich deposits help attenuate the fluoride, but it's also the flow of the groundwater. You know, it's hydrology as well. It's a number of factors, and that makes it complicated. In other words, based on the state of our science, on the hydrology and the geochemistry side, I think it's fair to say that we cannot predict where the high fluoride well will be or the low one. And so that makes the testing all the more important. If anything, you know, also because of my work on arsenic in other countries, in Bangladesh and India, I would say, if anything, by testing wells, we have essentially probes into the subsurface, and we are learning broader mechanisms in geochemistry or hydrology that affect the quality of groundwater. Very good question.
Great,
all right,
thanks.
I think we're, yes?
There is actually one more question, mostly, but we can, I think this is a good point to ask it simply because we were just looking at the map with blue and yellow points. And did you have areas that switched from blue to yellow and vice versa, perhaps during the period that you were testing?
Maybe I'm going to let Radhika answer that one.
Okay.
So we did it in a, maybe 4 months or so. Maybe if we do it longer, there were some indication, or we were getting this feedback that, if you have more rainfall and if the level of water decreases in the wells, that would show an impact. But we had done it only in 3 months. So we have not really done an extensive study yet to know whether those levels changes or not.
Was the question about the fluoride levels changing or people's behavior changing? Maybe Cassie.
I believe it was related to the fluoride levels changing,
okay.
because it was referring to the blue and yellow and what's safe and unsafe.
That's right. That's right. So I can say that from my work in arsenic, which is different from fluoride, there people often claim that things are changing, but more often than not, it's because the measurements aren't that reliable. And so we're seeing that in the subsurface, typically, if there are changes, they're gradual. It may be different in this situation, and so this is definitely something to study. Yeah. All right. I think
great. I can launch the next poll then.
Sure.
Yeah. Okay. All right, great. So the next poll, Lex, do you want to walk through this one?
Sure. So here I suggest that you zoom in a bit more on the map and you try, to, within an order of magnitude, try to estimate how many wells these students tested. And Radhika, how many were there total? On the order of 60, something like that?
Yes, like around 60 or so.
That's right. So imagine, how much work they did to do that. I will zoom in on the map as well so that you can, in case you're having trouble with it, so that you can still participate. But it's obviously a lot more fun if you zoom in yourself.
So it looks like a few responses have said 1,000 approximately. Most of the respondents have said that.
Very good, very good estimating. I think it's on the order of 1,200 or 1,300 tests that were conducted by these students. So you can see they worked really hard, but they did a fantastic job. Good. I think we're ready for the next question. Yes, excellent.
Okay.
Right. So now, one of you already sort of gave us a peek preview of that. Tell us if you zoom in and sort of navigate around this area, what do you think is the overall proportion of safe and unsafe wells? And the reason I'm asking that is that this will have implications for what solutions this sort of testing offers to people. Obviously, if all wells are unsafe, if all wells had been if all wells had been green, we would have brought some bad news to people, but not much else. And that would have been obviously a very sad situation.
Okay, so it looks like most of the respondents are saying 20%, and then we have a few saying 10%.
That's right. So I think it's a bit closer to 10% than 20%, but that's the general idea. So I have to, okay. So now I would like you to zoom in and try to find a village that has both safe and unsafe wells, so both yellow and blue dots. And using the little distance bar at the bottom left of the screen, try to get a sense of what the distance is from a typical yellow well, an unsafe well, to a blue well. And it doesn't matter, it will change, but give us the order of magnitude. Play around with it and then enter the response in the next poll that Cassie will put up. And as you zoom in, you will also get a sense of the landscape. There's some dry areas, some wet areas. I think if you zoom in all the way, you can actually see the individual houses as well. And the paths and the main, yes, you can see the individual houses. It's really it's a lot of fun actually to navigate.
So it looks like we have a response for 10 feet, a few responses for 1,000 feet. They're a little all over the place.
That's
so
right.
we have
right.
10 feet, 100 feet. We have most of our responses in 1,000 feet, and then one at a 10 miles response.
That's right. That's right. So in most cases, I think it's in more than 90% of the cases, essentially, in this setting, a family, and actually it's typically multiple families, maybe Radhika will tell you more about that. These are all government installed wells. These are not privately installed wells, and they're rather expensive to install. Many of those, yes, it's good to see the histogram, and I think that's right. So if most of the unsafe wells have a safe well within, say, 1,000 feet, what does that tell us, in terms of lowering fluoride exposure? Is that a realistic walking distance? How many times a day? Maybe in the chat box you can tell us, do you think this is helpful information, or do you think that the wells are too far from each other?
Lex, perhaps to help our participants, can you repeat the question?
Sure.
Since it's not a poll question.
No, that's right. So here, you have now, Radhika and I, we presented to you a situation where you have these villages separated by, a mile or 10 miles. Within the villages, you typically have multiple wells. In most villages, you have a combination of high and low fluoride wells. If the public health message needs to be, you should lower your fluoride uptake because it's not good for your children's teeth. There's even some evidence that drinking water with too much fluoride is bad for intellectual development of children. The map that you've seen, that you've been able to navigate, what sort of solutions does this offer? Does it offer a solution? Do you think there is hope for these people? Okay, so one person responded. So we're getting divergence responses.
Yes, a little saying okay, some saying too far.
That's right. No, but that's really summarizes it. I think maybe Radhika, I think it's better if you take over again now, because maybe you can also talk a bit about what we're thinking about the next steps, whether you find this testing useful or not, starting from that.
Yeah, so I guess the answer is very typical of our confusion in the field, because some people are saying yes, we can travel. Some people are saying no, but this fluoride, for them it is a lifelong thing. It's not like you die tomorrow. So they don't have that much of urgency. So this is basically a behavioral issue, and how important this particular problem is for people. So the answers, as you are rightly suggesting, the answers are all over the place, and we are still figuring out what we need to be doing. There definitely needs to be more information about this particular issue, and how we can maybe people can just walk for 5 minutes, but can they walk for can you and I walk for 5 minutes every day, go outside and get water and come back? So there are all these issues that we have to deal with, but that's where we need to do much more research, and that's where I feel that there needs to be science and social science together solving this particular issue. I'll start with I think we have a...
Can I add a couple more things to that, Radhika?
Sure.
So I can tell you in a different context, in the context of arsenic, both in India and in Bangladesh and in Pakistan, there the distance between the wells is typically more like 100 feet or less. But there still is this mixed distribution of high, safe and unsafe wells. I can tell you that when we do a campaign, when we do the testing of all the wells, blanket testing we call that, then with some reinforcement, a strong message, at least 50% of the people who have an unsafe well will switch to a safe well. So it's a bit of a glass half full or half empty situation. Some people tell us, wow, that's wonderful. By testing, you're lowering the exposure of half the exposed population. Others tell us, but you need 100% of the people's exposure to be lowered. And of course, as Radhika pointed out, this is where social and earth and health sciences need to work together to come up with ways of convincing people this is important. I'm surprised no one yet has mentioned treatment, Radhika, and I was wondering if you could briefly give your experience with that.
So in terms of treatment, what we've seen is that the government is trying their best to have these treatment plants, but when we go there, some are working, some are not working, because when you go to these villages, this treatment, it's like a container that's placed next to the hand pump, and people don't know what to do with it. Okay, it's there, and then there is a person who comes, has to maintain this, and then that person lives in the city, so that person has to come here in this village often to see how it's working or not working. Then there are these other filters, but the cleaning agent of the filter cannot be done by a non-specialized person. So if, we need a specialized person to come in, and usually in these places the government has 2 or 3 public water health department people, and they have a lot of responsibility. Imagine, like, thousands of wells we have done so far, and imagine just the testing taking so much time. So imagine the treatment, and these are low resourced departments, and they have to figure out all of this, including talk to many people. So it's not really an easy solution. For us, we are figuring out whether we should go with the treatment, or whether we should tell people that maybe walking 5 minutes away from here, it is a hassle, but it is much better than having fluoride, high fluoride water, and then relying or not relying on the government's provision of treatment, which cannot be given to all the villages that have high fluoride because of the expensive proposition that the treatment of water requires. So those are some of the things that we're still dealing with. This is our second phase. We've at least done some testing of the area, and we've seen what works, what doesn't work. Training of people took a lot of time. So, but the treatment is, I guess that's something to learn from in our next phase. Lex, I don't know if you want to add anything to that.
No, I think it might be, especially if you look at the time, it's time to look at the video, which will make it more alive.
So here is a video that we had prepared just to give you a feel of what the place looks like, and just see the type of things that we were able to do given the short amount of time.
दांत में खराबी आ रही है, दांत में खराबी आ रही है, तो हैंडपंप और दांत में खराबी से क्या कनेक्शन है? पानी खराब क्यों है? पानी में क्या है? हाँ, टेस्ट में ये बहुत important question पूछा आपने.
As your bottle, that will be for sample collection. Right. Start survey CTO.
No, UBL.
That's right. What is it?
ये तो motorized.
I think so, huh?
हाँ, motorized.
ની પીવાનું છે તે અમુની નાટકમાં તમને બતાડું કે આપણે એવું પાણી પીવાથી અરે પાણી પીવે એના હેન્ડપંપ એના નામ કટરા સાફે સાફારું કેવું ઓલરાઈટ જગા જગા હેન્ડપંપ પર એવો પીળો નિશાન લગાડી દેજો લાલે સદવાળું પાણી મતી પીવજો નીલા સદવાળું પાણી સમુ પીવજો
मालूम पड़ जाए खराब હોય તો પીલી પટ્ટી લાગશે અને વારું હોય તે नीली पट्टी जाता नहीं तो जांच करने के बाद अगर खराब पानी है तो वो लगेगा रहेगा. ये पानी ले लिया और खराब पानी है ना पहले महीने
Shake it as hard as you can. So it doesn't, okay. All right. So now you can have one shake.
I'm having performance anxiety.
I thought you were immune to that.
Maybe not.
So it's
हाँ. Two. So you don't need to. Essentially, it would go to 2 automatically.
right. So then what?
And then you. It's at that margin, but yeah, definitely 2. Okay, so we'll see what it gives. In fact, you could use that.
So I think maybe the language was not something that they understand, but at least the graphics were able to show some of the things that we did at the study area. So just wrapping up now, we don't have much time, so maybe what did you learn from this particular presentation? If you can write it in the Q&A box, that will be great. Anything that popped up or anything that you thought that would help you in your quest for knowledge.
So we do have a couple of questions, and while we give folks a chance to kind of respond to this question you have, I'll go kind of backwards here. We had a question come up about how much water do the locals typically collect with each trip to the wells?
Good question. I wouldn't know actually there was no question. There was no, we didn't do a survey. So I have, I'll probably just have to guess that maybe, I think one container, like a small container, which can include like, enough water for, 2 or 3 people. So in the morning, and then they would go in the evening to collect again. Days are very hot, so usually they prefer not to go during the daytime, but that varies because sometimes you need water to wash your clothes, sometimes you wash, there are cattle, animals, all sorts of things, so it will definitely vary, and we have to include that question in a questionnaire, in a survey. We have not done any formal survey yet.
Okay, all right, thank you. So there was a question about the slides being shared, and we can absolutely share the slides. What we can do is send a copy of it when we send a recording of this video. Okay, now I'm going to go back to the beginning because a lot of people now have questions, which is great. We had another question about rocks or land. Are there specific rocks or land that absorb or take up fluoride more or less?
So certainly some rocks contain more fluoride than others. and others contain, for instance, calcium carbonate, which can prevent the fluoride from going into the water. So I think one significant part of the variability that you see in the well water fluoride is based on that. But then I mentioned the other part, which is how long does the water stay? If the water is rainwater that's quickly infiltrated and stays there for less than a year, it won't have time to pick up as much fluoride as the water that stays there for, say, 100 years. So there are a number of factors that come into play, and they're not always easy to separate. I think in terms of implications for solutions, mitigation, I think the next most important question is another one that someone raised, which is related, which is, will there be a big difference between the wet season and the dry season in the area, for instance? Because if you're encouraging people to go to a low fluoride well and they make that extra effort, you want to make sure that that well remains low throughout the year. And I think if we build on this project, that's probably something that Radhika and I will work with the same students.
Great, thanks. And these two questions are sort of related. Is it possible to test adults for when they were exposed to high fluoride and better understand the effects of fluoride exposure, or test students from the area? You know, if you're talking about long-term fluoride exposure and brain development. So is there a way to figure out who has been exposed to fluoride and its effects?
So I think the simplest way of inferring it is by collecting urine samples and measuring the fluoride in that. I don't know if you can do that with a kit or not, but the simplest is just to measure, of course, the person's water. In terms of the long-term effects, I'm not aware, because even the urine will reflect the more recent exposure. Maybe someone who specializes in effects on bones would be able to say more about that. I cannot.
Okay, thanks, Lex. So is it possible that the safe wells can also be contaminated with unsafe levels of fluoride? Like if the water with high fluoride content ends up taking over and more pumps become unsafe over time, and if so, how can that be combated?
Yeah, no, so that's been an issue also in the arsenic context. If you direct people to a subset of wells that are low in fluoride, could you essentially be drawing water from the high fluoride areas? I think given this sort of 10% level here, and that hand pumps, you know, it's not like pumping with a motor, large volumes. I doubt if there is variability of the time, over time, I don't think that would be because of this redirecting of the usage. If you have a large city that's drawing with large pumps, that could be a different matter. Again, testing, monitoring, involving the local community and making these measurements, those seem to be the best things. If there are some uncertainties like temporal variations, I don't think this eliminates the option of using the safe wells, because right now there are no better ones. You know, Radhika pointed out that treating is possible, but it requires a lot of maintenance and monitoring as well. And so we like, to the extent possible, let the subsurface do the treatment of the water for us before it's used at the top.
Okay, great, thank you. So does fluoride enter the food chain through irrigation?
So I'm not sure about that's a good question. What I do know is that food is a significant source of fluoride, can be. And in fact, some people say that this fixed level, the World Health Organization level of 1.5 milligram per liter, should be adjusted locally based on people's diets and how much fluoride the people's diets contain. But more important in the diet is actually how much calcium people take up. It turns out that if people have a calcium-rich diet, this can help mitigate the effects of the high fluoride. So diet is important. But there's a lot to learn still from that.
So related to that answer, Lex, I think another participant has asked, what's the reason, perhaps the chemical reaction that keeps fluoride from dissolving when calcium carbonate is present?
Okay. Well, there's a mineral, it's called fluoride, CaF2. Essentially, at a certain concentration of fluoride and calcium, if the product of these two concentrations, the fluoride is actually to the square power, for those of you who are interested in the chemistry, if it exceeds a certain level, then this mineral will precipitate the fluoride. And so that will, and anytime you add more fluoride, it will precipitate again. So that provides sort of a cap. Unfortunately, even when the calcium levels are quite high, that is not enough to keep the levels below 1.5. So that's why you can have wells with 10, 15, even 20 milligrams per liter for fluoride.
Okay, all right, thank you for clarifying. And we have one last question here. So did the locals, do they realize now which water pumps are unsafe and are only using the ones that are blue? And I think this gets at probably a behavior question, and also you know, how this study has changed practices and behaviors. So if either of you or both of you would like to take the last question.
Yeah, so I think it's a very important question, and again, as I was saying, that it is, we need to learn a lot from what is the incentive that will make people switch to a safe well. And there are some who said, yes, you know, thank you for letting us know, and we can go to a nearby well. The others are saying that, well, this is life, it is a part of what, you know, we have grown up with. This well has given us water, and so our kids are also having water from the same place. So some required a lot of you know, discussion, and then it was not like an outsider like me discussing this. This was the best part about our study, was that we are not like researchers coming and saying, outsiders, you know, we are trying to convince people what needs to be done. We are showing, here is the data, here is what, you know, the study shows, here is the data that your people have collected, and the citizen science, you know, the college students have collected. So it is the college students who are convincing their own relatives, it's their own, you know, villages, and still it is taking a lot of time for people to get convinced, even though their own people are suggesting all these things. So we are working with the government, state government and local government very closely to see how are they planning their policy level interventions, and what can we do to provide the data, because clearly it seems like data is missing. They did not have this database that we prepared, and so now at least we can show that these are the problem villages. And so if we can concentrate on those problem villages, and if the government policies are also going along with the data driven approach that we have, along with the citizen science component, I think we have something to offer. Now, how many people change their behavior is yet to be seen, but I think we have the elements of what could lead to a much better system, where we have the government will, as well as the data and the science component, as well as citizens who are helping us, or who are helping to gather this data to change their own practices. So answer is yet to be known. Maybe, Cassie, if you invite us again for our next session next year, we will have that question.
Yeah, so TBD for sure. So of course, as soon as I said that was the last question, we had a couple more pop up. So we're at 3 o'clock. So, but if you would like to stay on, if you need to go, feel free. But if our presenters can stay on for another minute or two to get through these questions. So are there any villages with only unsafe pumps?
So there were there were 2 villages that we went to, and of course we based it on the data that I had specifically gone to that village where there were a lot of hand pumps that had high fluoride. So I would say that village that we had gone to, Rajgarh, had around 70% wells that were infected. So, and to reach to the rest, they had to walk a lot, including, you know, main road that they had to cross. So it's not like the government did not know about this. They know that this village is a problem, but now they have the data to actually base it on. Earlier on, it was like, yes, we did this study, we did this data collection. It was, you know, many years back. So now they know that it is still there. It is, that village has at least 70%, water points that are that have high fluoride. So yes, there are villages that have, all of them, but we are still in the process to see whether we have covered all the water points or not. So we need to see, that is again a check, quality control as well as check on whether we have covered all the water points or not is something that we will soon be conducting after, this coronavirus period is over.
Okay, great. Thank you. We may have lost Lex, but I'm going to continue. I think he had to bow out, and there's another meeting. So, okay, the last question is actually for you, Radhika. So, can you talk about your experience with the Bhopal Union Carbide environmental disaster and the aftermath, unrelated to sort of this this presentation, but if you could provide some overview, I'm happy to connect attendees with Radhika for follow-up questions as well.
Great. So yes, Bhopal has been famous and infamous for the Bhopal gas tragedy. And I am one of the survivors of the Bhopal gas tragedy. The winds were not coming to our side of the city, so I happened to survive, and so did my family. But many people were not lucky enough. There were a lot of relief work that was done, but it was not enough. And there were a lot of research that needed to be done, which didn't come to public eye. So that's again another case where citizen science is very important. So all the youngsters who are watching this, please do not leave your science to books. You have to use the science for citizen science and relate it to the environment. And that's something that I learned, that when I was studying at that time, and I can send a paper that was published on this, that the books did not carry much about Bhopal gas tragedy. I learned it from, my mother and from other relatives who were protesting to get, their social justice. And there were a lot of, injustices going on at that time. So yes, people are still, they have health ailments. We know that that generation as well as the next, they've had many health related issues. We know it was because of the gas tragedy. So, things I think are, that history, that part of Bhopal history cannot be forgotten. And it was a big environmental injustice that happened in my city. And I just hope that we can use and be empowered enough to walk towards a citizen science approach, so that we don't let all these injustices happen to our places and to our environments. And I can go on, but given the time, I can definitely connect Cassie with the references that I have.
Okay, great. Yeah, so it would be great. I think what we'll do is we'll share the slides for this presentation along with the paper that you had mentioned, and we'll share that along with the recording of the session. So yeah, I think that actually ends the session quite well, that we can encourage our viewers to think about science beyond books and how you as citizens can contribute very important work to scientific research. So Radhika, any other final thoughts from your side?
Just another thing, because I keep learning from Lex a lot. So, there is a podcast, Cassie, I'll send that podcast also between Lex and me. I'm asking these questions, and he's, basically giving like an overview of how citizen science can, do things. And there are also different approaches there. So there are two podcasts, one from an environmental journalist in India. She actually traveled with me to Alirajpur and, did this whole, podcast as well as article. So I'll send you those. I think those will be very good for students and everyone to think about this approach and get some new ideas.
Okay, perfect. Thank you. And for our viewers, if you have any additional questions that have come up, or if you'd like to ask Lex or Radhika very specific questions, just send an email to me. I'm happy to connect you with them. But otherwise, thank you again for tuning in today for another session. Thank you, Radhika, for your time and for sharing your experiences with us. And as I mentioned, we have 2 sessions of EI Live for K-12 students and educators left. And they are going to be on Wednesday, June 24th from 2 to 3 p.m. Eastern Standard Time, and Monday, June 29th from 2 to 3 p.m. as well. So with that, we hope everyone has a good rest of the day, and thank you again for tuning in.
Thank you.
Thank you. Bye.